In this lesson, we're going to be dividing decimals. Okay, we'll start with some definitions. When dividing whole numbers, we need to make sure we rewrite our division problems. In this problem, we have 12 divided by 4. So as I write this, I say it out loud. 12 divided by 4. I call this area the house, and then the 4 is out here knocking on the door. All right, the technical names. The number in the house is your dividend. The number knocking on the door is the divisor, and the answer is called the quotient. Here are some steps to help you remember what to do when dividing. First, we'll divide, then we'll multiply, subtract, then compare, and finally bring down. To help you remember the order, you could say, does McDonald's sell cheeseburgers? In our first problem, we're dividing by a whole number. We have a class of 27 students that were having a picnic. They wanted food and drinks for the picnic. The total cost is $93.15. The question is, what price will each student need to pay for their meal? So if I have a total and I'm finding the cost per student, the cost is what's being divided. When working division, it's important to know what is being divided. To divide, we will work with these as with whole numbers. Place the decimal point in the quotient above the decimal point in the dividend. So $93.15 is what's being divided. So it is inside the house, and the 27 students are knocking on the door. Okay, I don't have a decimal out here, so I will just place this decimal in our answer. And now it's time to divide. 27 won't go into 9, but 27 will go into 93. So we need to figure out how many times 27 will go into 93. It will go in there 3 times. 3 times 27 is 81. We subtract and get 12. Now it's time to compare. 12 is less than 27, so the 1 is brought down. So now we'll need to see how many times 27 can go into 121. 27 will go into 121 4 times. 4 times 27 is 108. Subtract, and now I have 13. Compare. 13 is less than 27. Bring down. Now I need to try 27 into 135. 27 will go into 135 5 times. 5 times 27 is 135. Subtract, and we're at 0. So each student's meal will cost $3.45. Now let's try it out. All right, in our first problem, we have 9 48/100 divided by 15. Don't have a decimal out here, so then I will place my decimal in the answer. All right, 15 will not go into 9. So I'm going to use a 0 to hold that place because it is in the whole number place value. All right, so now we'll take 15 into 94. 15 will go into 94 6 times. 6 times 15 is 90. Subtract. 94 minus 90 is 4. Compare. 4 is less than 15. Bring down. Now I'm taking 15 into 48. 15 will go into 48 3 times. 3 times 15 is 45. Subtract. 48 minus 45 is 3. All right, we're not finished with this problem. We'll add a 0. Bring down. Now 15 will go into 30 2 times. 2 times 15 is 30. Subtract, remainder 0. And we have our final answer. Okay, let's take a look at a couple of definitions. First, we have a terminating decimal. This type of decimal will stop. You won't have a remainder like 5/10 or 1 25/100. Another kind of decimal we might see is a repeating decimal. This type of decimal repeats a digit or maybe a group of digits. And to show this, we'll draw a bar over the digits that repeat. So for example, we'll do 1 27/100, but we'll put a bar over the 2 and 7 if we ended up with an answer that repeated the 2727. Here are a couple more examples. If I have the number 75 and then the decimal, and then I have 3's that repeat, I'll write this as 75 3/10 and put the bar over just one number 3. Or let's say I have 1 and 2, but then the 5's repeat. I'll write this with the 1 decimal 2, just do 1 5 and put a bar over only 1 5 because that's the only thing that's repeating. All right, let's look at dividing a decimal by a decimal. In this problem, I have 475 thousandths divided by 500ths. All right, so in this problem, this number will go in the house, and the second number goes here. It's knocking on the door. First of all, we will need to move our decimal. Technically, what's happening is we're multiplying by 100. Okay, I call it bump bump. What you do to the outside, you must also do the same thing to the inside. All right, it's very important not to have a decimal in your divisor. All right, so the decimal next. Sometimes it's easier to go ahead and rewrite your problem. Okay, always start by putting your decimal in the quotient so that you don't forget it later on. All right, so here we'll go. So 5 doesn't go into 0. 5 doesn't go into 4. 5 will go into 47 though. It will go in there 9 times. 9 times 5 is 45. Now we subtract and we get a 2. Compare, 2 is less than 5, so then we can bring down. Now we're going to take 5 into 25. It will go 5 times. 5 times 5 is 25. Subtract and get 0. Now that I end up with a 0, I have nothing left to do. 9 5/10 is my final answer. For this final problem, we're going to take 14 thousandths into 5 6/10. First of all, we cannot have a decimal here in the divisor. So we'll do 3 bumps, which is the same as multiplying by 1,000. I don't have 3 digits inside to move my decimal place 3 times, so I will add zeros. That does not change the value because they are after the decimal. Bump 3 times, place your decimal in your quotient. Now we're going to take 14 into 5, but that doesn't go. So we'll take 14 into 56. It'll fit 4 times. 4 times 14 is 56. Subtract, and we get a 0. 0 is less than 14. Now most students will, or some students will try to stop here because they've gotten a 0 as an answer, but that would be incorrect. 14 does go into 56 4 times, but the problem is taking the 14 into 5,600. We cannot leave these two places blank between the 4 and the decimal. So you can just plug in zeros, but the technical thing we did was we took 14 into 0, went 0 times, multiply, subtract, compare, bring down, and everything's a 0. Goes 0 times, subtract, and that would keep going. So it's a shortcut just to plug in those two zeros.